Hi, welcome to the last video of this module where we look at 3 examples to reinforce all the things that we have learned thus far. Let's proceed to our first question. A shelf can hold only 7 books. 7. Given that there are 11 different books are available, find the number of different arrangements that can be made to fill the shelf. This is a very straightforward question. We have 11 books, but we only want to permute 7. So using your calculator, if you fill in 11 permute 7, you will get the answer 1,663,200 ways. So again, this is a pretty straightforward question. Let's move on to the next one. 5 actors and 8 actresses are available for a play which requires 3 male roles and 4 female roles. So let's work with the actors first. There are 5 actors, but we want to permute only 3. For the actresses, we have 8 of them, but we only want to permute 4. Again, there's a total of 7 people that we want to select. So imagine a box full of 7 rows, and each can be permuted. So in that case, the answer is 5 permute 3 multiplied by 8 permute 4, and this yields an answer of 60. This one is 1,680. Now we multiply this, and this will give us an answer 100,800. Again, this is a very straightforward question. By using permutations, we can find the answer pretty quickly. Now let's move on to the last question. Calculate the number of arrangements of the letters of the word include if all the consonants are together, and there's also questions about the vowel. Now first of all, we need to understand what's a consonant and what's a vowel. Now let's answer part A here. Now the vowels here are all the letters of A, E, I, O, and U, and the consonants are the rest of the alphabets. Now let's split this up here. If I have a vowel and a consonant, there's 3 vowels, I, U, and E, and I have 4 consonants, which are N, C, L, and D. Okay, so there are 3 vowels and the rest are all consonants. So the question here is, what if all the consonants are all together? Now if I were to draw a box here, I will have the 4 consonants, which is N, L, C, and D. Now we know this can be permuted in 4 factorial ways. Now remember what we did in our previous module. Now we need to assume this as one block, and then we need to multiply this by the remaining 3 consonants, 3 consonants here, 3 vowels here, I'm sorry, the 3 vowels that are remaining, plus this block 1 that is considered as 1. So we have 4 factorial. So the answer to this question is 4 factorial multiplied by 4 factorial, which is 576. Now the thing that we need to keep in mind here is this operation right here. Once you have taken care of this restriction, which is the consonants being together, once you have taken care of this, this needs to be considered as a block that can be rearranged between the 3 remaining vowels. That's why instead of doing 3 factorial, I have to do 4 factorial. And this will give you the answer that we need. Let's move on to the next part here. No 2 consonants are together. Again, if I were to draw a box, now let's fill them up with letters. So let's start with consonants here: N, C, L, and D. Now in between we will have all the vowels. Now again, this arrangement meets the requirement, but again the letters can be permuted, meaning the N can switch places with C, it can switch places with L, and it can switch places with D, all the other consonants. So each letter in its position can be permuted. Now there are 4 consonants, so this can be permuted in 4 factorial, and then I can permute the remaining vowels in 3 factorial. So this will give me an answer of 144. The last part here, it must begin with the consonant and it ends with the vowel. Again, let's meet the restrictions first. So since it says it must begin with the consonant, we know that there are 4 consonants, so I can arrange in 4 ways. And then the last box here, it must end with the vowel. There are 3 vowels, so there are 3 ways. Now I am left with 5 boxes here, which I can rearrange in 5 factorial ways with the remaining letters after meeting the conditions that are required. So to answer this question, it's pretty straightforward again, which is 4 times 5 factorial times 3. So this will give you an answer of 1440. So we have completed this question. So I hope the 3 examples that we have discussed gives you a better idea how to use what we have learned to solve these problems. Now the last question that I discussed actually is a Cambridge question. So that's the kind of question that you'll be asked. So keep in mind a few things that we've learned, especially with dealing with the restrictions first and the permutations. So go through the examples once again if you're not very clear, and if you have questions, please post them on the discussion board. And if you feel like you're ready, go ahead and try the practice quiz and then move on to the module quiz. Good luck, and I'll see you again in the 3rd module where we will be discussing combinations. Bye.